So this video is going to go through question 5 of sample paper D. So the blue paper you can just see there on the side. And this question is all got to do with the parabola and the ellipse. So I'll just get this in focus first. So the image below shows a model airplane on a display stand. Part A tells us shown is a dimension drawing of the display stand. The curve AB is a semi-parabola with vertex at A. Using dimensions given, redraw the stand on the baseline below. So the parabola is on its side there, at the top, the vertex is at A. So usually what I ask you to do is, if you want, you can turn your page with the parabola so that's upright like this to make it easier for you. For this video here, I'm just going to keep the page the way it's usually set up in the exam. So the first thing I'm going to draw is the outline for the parabola. So the box that's going to fit inside. So my baseline here, you can see it's 80mm long, and for point A I have to go up a further 16mm, so you can see 10 and 6 there. And then I'm going to take across my 80mm and take this line up. So now here I have point A, that corner there is that corner there, and then I go up a further 46, 7 and 7. So 46 and then another 7 and 7 again gives me 14. So corner B is this corner here. So what I want to do is draw the parabola inside that box. So the first thing we're going to do is divide our sides into a number of equal parts. So I'm going to divide into 5 equal parts for this, so I have enough points on my curve. I'll label it 1, 2, 3, 4, 5. Because we're only drawing half the parabola, we can divide this full line here into 5 equal parts. If that was going to be a full parabola, we divide half it into 5 equal parts if the vertex was in the middle. So we can divide the full line from here to A into 5. So 1, 2, 3, 4 and 5. And then all it's going to do is using sliding set squares, join the endpoints to divide our line up. After my side divisions, they all connect up to A. So remember, our parabola is going in this direction here, so these are all our side divisions on this way. They all connect up to A like this. And then for these lines here, they're taken straight across. Or if the parabola was standing upright, it'd be going down. So 1 hits off 1 here, 2 hits off 2 there, 3 hits off 3 there, 4 hits off 4 there, and you can see 5 already connects to 5 up here. Now all it's a matter of doing is drawing my freehand curve. So as always, draw it lightly with one continuous line, and then when you're happy enough with it, you can then go over that heavy. Now with that complete, I can then start to finish off the rest of the outline of the stand. So the base of the stand It's just that rectangle there. There's a radius 46 curve. At that point there. Level line going straight out. That goes out a distance of 10 mil. And then I go up 10 here, and then join that sloping line back to that corner there. And that completes part A. Part B then is all got to do with this ellipse here. So shown is a dimension drawn on the model airplane. The curve ABCD is an ellipse. AC is the major axis and BD is the minor axis. The lines RS and TU are tangents. Part 1, given the major axis and the minor axis BD below, draw the ellipse. And then part 2, use the dimensions given, complete the drawing of the model airplane and show all points of contact. So we're already given our major and our minor axis. We're told it's 120 by 60. So first thing we'll do is use the concentric circles method to draw my ellipse. So I'm going to draw my major auxiliary circle and I'm going to draw my minor auxiliary circle and then divide that up into 12 equal parts using my 30-60. So all this is drawn lightly. The only part that's going to be heavy is the actual ellipse itself. So with each of my points, each of my divisions here, for example the left hand side, where that line hits the major axis, I take it down. Where the same line hits the minor axis, I take it across. And where they meet gives me a point on the ellipse. And I'll use colour just to show that once again as an example. So that yellow line, it goes out to hit the major, it goes down and across from the minor, and where they meet gives me that point of contact there. And it's the exact same again all the way around for the top half. Points go down and across. And then for the bottom half we just do the opposite. Where the divisions go, it goes up and across. Then we have our bottom point here, we have our widest point here, our top point here, and our widest point there. And with this question here, we can see the full ellipse. So we sketch it out lightly first. And then after you're happy enough with your curve, you can go over it heavy then. So making sure it's one continuous line. that's part A then complete. Part B then, I guess, is to draw the rest of the airplane itself. So I'm going to get the outline here first. So the first thing I have is a radius 14. I can see that there for the width of the semicircle here. So if I take 14 out one side, 14 out the other, it gives me a total of 28 for the width of those two lines there. So 14 there, 14 there, and I'll just take two light lines like that, and it goes up 8 from point B. So I'll just take my center line and extend that up a bit more there, and a bit down there as well. So 8 mil up. That gives me the center of my semicircle. And as a result, that gives me point U there, and then it's a radius of 14. Like that there. And then I go up a further 32 for this line here. And then to get the top point, it's another 8 mil up then after that. And it goes 32 mil out each side. So 32 mil out there. And 32 mil out there. And then for R and T, so I point S as well here, there's going to be tangents connecting them. So if I go over again, the line R, S and T are tangents. So from this point here, I'm going to draw two tangents to connect off of that arc, or sorry, that semicircle SU there. So the first thing we always do when we're drawing tangents to a point inside a circle, we join the point to the center, which we already have, and then we bisect that line. So taking a distance greater than halfway, swing an arc on both sides. We then draw a semicircle on the side of the tangent. For us, it's going to be on both sides. I'm just going to draw one there, and then where the semicircle hits our circle here, that's going to be our point of contact. So that gives us our tangent there. And instead of drawing the semicircle on the other side, I'm going to take the height of that point of contact there straight across to give me the point on the opposite side, and I get the same result. And that gives me the tangents R and T there. And then the rest of that arc is going to be heavy as a result. Then for the lower half, so you already have our two lines going down here. Once again, from D it goes down a further 8 mil. Take that across and have that heavy going down there and there. We then go down a further 34 and then 8 after that. So 34 and another 8 for the base. And the base we're told is 80 wide in total, so we go 40 out each side. And our base is heavy, and from the center of base here we can see that we have a line going out there and there at an angle. So from here to there, and from here to there. I'm going to leave it lightly for now, just till I get my heights. So if I go down, you see there, I took down my 8, I have that there, and then I have a radius 16 from that 8. So you can see there I go up 8, and then I have my radius 16 here on that line. So I go in 16, and I can go up 16. And I'll go in 16 here as well. I can now draw my quarter circles that are going to fit inside. So there, and across heavy all the way. And then now I can see that my heavy line only goes down to there and there for the outline of the base of the stand. And that completes question 5 of sample paper D.